far, we've just been typing code into CodeSculptor, and we type statements one after another, and they get executed immediately when we run our program. This is fine for simple programs, but a very powerful construct in programming is the function. What a function is a piece of code that you define that you can execute later. And so you only execute the code inside a function when you call that function. And I can call the function more than once. So this becomes a very powerful programming construct. I define a block of code once, and then I can use it many times. So in this video, we're going to talk about how to define a function, and we're going to show some simple functions and some simple calls to those functions. All right, let's write some functions. Now, before we actually type any code, we have to think about what we want. Beginning programmers often just start typing before they think about it. And before I write any function, I should decide what the function is going to do. And a good way of doing that is to put it in a comment. So I am going to write a function that computes area of a triangle. Okay? And I want to see all your functions have comments like this. You should always put a clear comment that says, this is what this function does. Now I'm just going to type the function and then we're going to talk about it. And there we are. Here's my function for computing the area of a triangle. All right? So I want to talk about two parts of the function. The first, which is line 2, is called the header of the function. The second, which is the rest of it, is the body. Okay, so what is the header? The header tells you about the function. So it starts with the keyword def. Def is short for define, and you're telling Python that you want to define a new function. Then I have the word triangle area. That is the name of the function, and you can choose any name that you'd like. All names that are valid variable names are also valid function names. So you should pick a function name that is indicative of what the function does. So I'm going to compute the area of a triangle. I want to call my function triangle area. Then we have a parenthesized list of parameters. And in this case, this function takes two parameters, the base and the height of the triangle. Now functions can take 0 or more parameters, so I could have 0, 1, 2, 100, however many parameters you need to compute whatever it is that you're computing. Okay? And you should also name your parameters in a way that's obvious to someone who's using or looking at your program. Here, base and height are obvious names for the elements of a triangle. Okay? Then we have a special character. At the end of the header is a colon. A colon has huge significance in Python. This means you're about to start a new block of code. And you'll notice the body of the function, which is the rest, and which is this new block after the colon, is indented. It doesn't matter how much it's indented, but it does matter it's indented by the same amount. And this has significance. When you stop the indentation, the block of code is done. Okay? So everything that is indented after that colon is the body of the function. And you can see I have two statements that are the body. The first one is actually computing the area, and you can go to Wikipedia if you've forgotten the area for the formula for the area of a triangle. It's just 1/2 times base times height. Okay? So I'm computing that on line 3. Then on line 4, I am returning that area. Okay? So what does return mean? Return is another keyword in Python that says this is the output of that function. And so you can output one thing from a function. In this case, I'm outputting the value of the local variable inside the function area. Okay? So let's run this program and see what happens. I keep hitting the run button here, nothing happens. All right, this is significant. This defined a function, okay? No code executes when I run this program. Why? Because a function is a piece of code that I want to be able to execute later. It only executes when you call it. So let's actually call this function. Let's say, a1 equals triangle area. Let's have a base of 3 and a height of 8. Now, beginning programmers often will just run this and say, hey, great, it works, because you get any old output. Let's think about it first. What is the actual output that's expected here? Let's print A1. I assume that a triangle with a base of 3 and a height of 8 should have an area of 12. Let's see if this actually works. It does. Okay. Now, I want to point out here. I assigned this to A1, and then I printed A1. What did A1 get? A1 got the output of the function triangle area. What is the output? The output is whatever the function chose to return after the return statement. So in this case, it was a variable area which had been assigned to the 1/2 times base times height. Okay, let's try it with something else. A2 equals triangle area 14 and 2. Okay, print A2. What do we expect the output to be here? I had expected to be 14, and lo and behold, it is 14. Now, I want you to think of these functions as a box. And this box has a name. In this case, it's triangle area. And there are some number of inputs. In this case, there are 2 inputs, and some number of outputs, 0 or 1. In this case, there's 1 output. Okay, the first input gets named base. The second input gets named height. Something happens here. We create an output. We call it area, and then it goes out. Now, the key point of this is these names, base, height, and area, they only exist inside this box. They only exist inside the function. You don't actually use them anywhere else. Right? And what's happening when I call the function, triangle area, and I call the function by using the function name in the parentheses and giving some values, 3, 2, right? What happens is 3 goes in here, 2 goes in there. So base gets the value 3, height gets the value 2. I compute the value of the area, okay, which becomes 3, and out goes 3 on this side. So if I were to print this, I'd get 3. If I'm going to assign it to A would become 3. Okay? This is valuable for many reasons, right? A function is now a black box. I don't care what's inside of it. I don't care what's going on in this squiggle here. All I know is that there are 2 inputs, base and height, and 1 output. And I can just use it. I read the comment. I know what it does. Okay. When I'm implementing the function, I don't have to care how you call it. All I know is these 2 things are going to come in the input, and now I can implement it in here, 1/2 base times height. Forgive me for abbreviating base and height as B and H. That computes area. This goes to area, right? Base goes to here, height goes to here. The output of this goes to area, and I get my output. All right, back to our code. Let's write some more functions. Let's write a function that converts Fahrenheit, if I can spell, to Celsius. Okay, so let's define a function. We use def, and we give it a name that makes sense. Fahrenheit 2, we'll be clever with the number 2, Celsius, and we take a variable name. We'll be clear about that too, that the variable is the value in Fahrenheit of the temperature. To convert to this, I'm going to say Celsius equals 599 times Fahrenheit minus 32. And we will then return Celsius. Okay, so now we have a function that takes a single input, just the value in Fahrenheit, and returns an output in Celsius. Next, we should test it. We shouldn't just trust that it works. So let's say C equals Fahrenheit to Celsius. Let's take some values that we know the answer. Okay. C1. Let's copy, paste, 212. So I know freezing and boiling. And we better make this C2. Let's print this out, C1, C2. I picked these because it's freezing and boiling, so I'm expecting 0 and 100 to come out, and they do. So I probably wrote this correctly. Okay? Maybe I don't like Celsius. Okay, I'm a big fan of Kelvin. I really feel like, absolute zero is my friend. So let's convert Fahrenheit to Kelvin instead of Celsius. So again, I'll give it a useful name. I'll name the parameter correct. I'll spell it correctly. Okay. Now what do I do? Well, hang on a second here. I have a function that converts from Fahrenheit to Celsius. I know that Kelvin is Celsius plus 275.13 or 273.15, sorry. But I I already know how to convert to Celsius, so it would seem silly to try and write that code again. So let's not. Let's call our function. Inside of functions, I can write any code, or I can use any code that I would use anywhere else. So if I already have a function, I can use that too, right? And I know that the Kelvin value, I should be consistent here, not use bad variable names. Kelvin value is simply the Celsius value plus 273.15. And now I can return Kelvin. All right? Well, I should test this. K1 equals Fahrenheit to Kelvin. Again, let's do some ones that we know. 212, K2, print K1, K2. All right, let's run this. And we get the numbers that I expect here as well. All right, I think this is very important for you to understand, right? Inside of a function, I called another function. All right, so let's think of this in terms of the boxes again. And hopefully you'll forgive me, but I am going to use single letters here because I can't write fast enough. Okay, so I had a function Fahrenheit to Celsius, right? There's some box here, okay? And it had one input, and that input was my Fahrenheit value. I did some calculations, which we know what they are, right? They're 5 nines, F minus 32. Okay, I get out the Celsius value, and that comes out. Then I wrote another function. I wrote a function Fahrenheit to Kelvin. Okay, that's also a black box. All right, in comes one input, something happens, we compute Kelvin, and Kelvin goes out. All right, now I want to make an interesting point here. I don't care how you implement Fahrenheit to Kelvin if I'm using it. So when I call Fahrenheit to Kelvin, so somewhere I call Fahrenheit to Kelvin with 32, I just want the right answer, right? I want the answer, I want this to evaluate to 273.15. Okay, how you do it, that's your business. So when you're in here implementing it, there's absolutely no reason why you can't say, hey, Celsius, I already know how to do that, F to C of F, right? But you could also recompute it. You can say, I like being messy, and I'll just say, instead of that, I'll say Celsius equals 5 ninths Fahrenheit minus 32. Okay? And then I'll go to Kelvin from there. All right? So there are many different ways to write a function. Which is better? I would argue that if I already have a function to do the job, I should not write the code again. You do not want repeated code. If I figure out, oh, I'm screwing this up, it's really 9/5 or whatever, right? You change it in one place and then it would be fixed in both, okay? I think this is pretty critical, right? But keep in mind, I have these boxes. I don't need to care how they're implemented as I use them. And once I have a function, it's available to me to use anywhere. All right, I want to show you one final function here. I want to show you a function that prints hello world, okay? This function, I'm going to call it hello, takes no arguments, right? Remember I said that we don't have to have any parameters or arguments, okay? And all it does is print hello world, okay? And that's it. All right, let's test it, as we should always test our functions. Let's call hello. Oops, I got to spell it right, or that definitely is not going to work. Okay, so what happens when we run this function? It prints hello world. Okay, that's great. That's what I expected it to do. Now, what's different about this function from all the other functions we've written today? Well, it does not have a return statement. This function, if I drew it as a box, would have no inputs and no outputs. Nothing comes into hello. There are no parameters. Nothing goes out of hello. There's no return value. So what happens when you try to assign it? Say h equals hello, print h, right? Well, there's nothing coming back. So what do you think is going to happen? Well, Python has the value none, and none means there's nothing there, okay? And so Python, if you forget the return statement, or if you don't need a return statement, it automatically adds one. So it's exactly like if I typed return none. Okay, this none is a special value. All right, so h gets the value none. I can print h and it'll say none. Now, why do I bring this up? Well, Usually you're not writing functions like this. You might write a few, but often you return a value and you expect it to return a value, but you forgot the return statement. And then none will show up here in the console for your variable. And I just wanted you to see this is probably the most likely reason. You should go look at your function again and see if you forgot the return. Okay, so this was a quick and dirty introduction to functions. Functions are extremely powerful and extremely useful, and every program you write will include functions. I've only scratched the surface here on what you can do with functions, and we will see them throughout the course. Pretty much every lecture from now on will use functions. Every project that you write will use functions, so you're going to get familiar with them pretty quickly. Right? I want you to keep in mind the things that I've said here, and hopefully the model of using a box with the inputs and outputs inside the box, those names stay inside the box, will be valuable to you. Don't forget the colon, don't forget the indentation, and don't forget the return. These are critical pieces of the functions. Hopefully, with a little practice, you'll understand and be able to use them well.